Okay, in the last section, we looked at x plus x, or whatever plus whatever, and now we're going to be multiplying. So let's choose a different letter. Excuse me. A times A equals. Well, in exponent laws in previous chapters, we've learned that if we have the base of something we don't see an exponent, we can give it an exponent of 1, and then we know we can add the exponents. A squared, circle your answer. Arbitrarily choose a value of A, like 5. On the left-hand side, it's 5 times 5, which is 25. On the right-hand side, it's 5 squared, which is also 25. Check mark. Learn how to do math on your own. Write down what you think. Then test it. It's so obvious sometimes. Just do it. Just do it. Just do something. Figure it out. Type it in your computer. Like, ask somebody. Test a number. It's just fun when you can check. Okay, 2A times 3A equals. Well, we already know that A times A is A squared, but we want to work on the numbers first. So we just multiply the coefficients. 2 times 3 is 6. Add the exponents. A squared. Circle our answer. Let me get a better squared in there. Okay, the next example off to the right is negative 3x squared y times 5x cubed. Remember, print off the notes. I'm going to be doing most of the questions on paper. I'm going to read some from the notes just so the videos aren't twice as long. So, negative 3x squared y times 5x cubed. Well, we just multiply the coefficients. Negative 3 times 5 is negative 15. X squared times x cubed, add the exponents x to the 5. And then we have a y there, so y. The next example down below, 2x times 3x squared. Well, multiply the coefficients. 2 times 3 is 6. Add the exponents. X has an exponent of 1. 1 plus 2 is 3. 6x cubed. The next example off to the right in the notes, ABCD times EFG is just ABCD EFG. All right, dividing. So we have 20x cubed divided by elementary school divided by negative 5 x squared. So we just learned that we can multiply the coefficients and add the exponents when multiplying. We're now going to divide the coefficients and subtract the exponents when dividing. 20 divided by negative 5. Well, I'm going to do the signs. It's positive 20. Positive divided by negative is a negative. Different minus. Notice I do the sign separately. 20 divided by 5 is 4. X cubed divided by x squared. Well, I'm going to subtract the exponents. 3 minus 2 is 1. So we get x to the 1. Who cares? Leave the 1 there. The next example off to the right. 30a to the 4 divided by 6a squared. 30 divided by 6 is 5. A to the 4 divided by a squared is 4 minus 2 is 2, so a squared. Further off to the right, 12x squared over 6x. Let's do that one. 12x squared over 6x. Well, start off with an over. We did this in exponents. Let's work on the numbers first. 12 divided by 6 is 2, or 2 over 1, whatever. X squared over x, we have a 1 on the bottom. 2 minus 1 is 1. 2x. Circle your answer. Don't care about the 1 on the bottom. More examples down below. 6x over 2 equals 6 divided by 2 is 3x. 8x over 2x. Well, 8 divided by 2, start off with an over. 8 divided by 2 is 4. X divided by x is gone, is 1. The answer is just 4. 4x over 2x squared. Well, I'm going to start off with an over. Now, 4 divided by 2 is 2. But I'm going to subtract from the bottom. I have an exponent of 1 on the top for the x. 2 minus 1 is 1. So I did the subtraction from the bottom. So the answer stays on the bottom. Okay, so that's multiplication and a little bit of division. Let's take a look at some more division. So 8x plus 4 over 2. Let's go down the page. Whatever. Now I want to separate fractions. Over plus over. The denominator is 2. Notice I got that out of the way. I had a plus sign on the top in between, so I put a plus sign in between. I had a 2 on the bottom, so I separated fractions. Now we just get 8x plus 4. See how much prettier it is up and down sometimes, especially with multiple steps? It's going to be prettier. Now we're going to keep going down. 8 divided by 2 is 4, so 4x. 4 divided by 2 is 2, 4x plus 2. So, one other little example off to the right. 1 over 2 open bracket 8x plus 4. Well, we're just distributing. Now there's 1's on top, so we don't care. We can literally just put this thing over 2, and then it's exactly the same question that we just did on the left. Interesting. So remember, a plus b over c is equal to a over c plus b over c. Because in fractions last year, we went this way, and now we're just going this way, separating fractions. So let's go for 9x squared plus 6x all over 3x. Well, separate fractions. Over plus over 3x, 3x, 9x squared, 6x. Simplify. 9 divided by 3 is 3. X squared divided by x. Subtract the exponents. X to the 1. 6 divided by 3 is 2. X over x is 1. Circle your answer. So whatever the sign is in between stays. So if I have a plus sign above, it's a plus sign in between. Because it was a plus sign in front, it's a plus sign in front. If there's a minus in between, there's a minus. Come on. Okay, so sometimes in the notes I don't have every single idiosyncrasy, but let's take a look at the next example. Negative 2x plus 4 over 2. Now, does this negative apply to the what? The top? The bottom? Well, we learned last year in M9 Remembers where the negative belongs, but we're going to put brackets around the fraction. Then we're going to separate inside. Brackets around, negative in front. Then we're going to simplify inside. Then we're going to distribute. Excuse me. Then we're going to distribute the negative into both things. So negative x minus 2 for our answer there. Then at the bottom, we have a whole bunch of ways that you can simplify stuff in short or long form, etc. So multiplying and dividing, simply multiplying the coefficients and adding the exponents, or dividing the coefficients and subtracting the exponents, obviously. Or, in big red, separating fractions and then doing the above.